Okay, our volume. We're going to have two methods of finding volume, a washer method and a shell method. So we're just going to do the washer today. And a washer is based upon a disc.
Like a wash.
Kind of
Like washers?
Yeah. This one kind of gets screwed up, but anyway. That's a circle, yeah. All right, so think of something like this. All right, here's where it's coming from. If I did like a volume of a cylinder, that would be V equals pi r squared h, right?
Yes.
Very basic formula. Okay. So if I put this in terms of a function, if I had a function here, something like this, let's do this. And what's happening is I'm going to rotate this thing around the x-axis. So if I picture this thing being rotated around the x-axis, here comes the other part right here.
Okay.
Does that make sense? So making something like, even though my piece is broken here, but making something like this. That piece.
Okay.
So this would be that x-axis right here. Does that make sense? So you get that curve and then it's rotating around.
Okay.
All right? So what's happening here is we're going to take a section out of here. And if you take that thin slice, or however wide you want to make it, it's a cylinder. It ends up being just a disc.
Okay.
Does that make sense?
Okay.
So that would be your pi r squared h.
Okay.
That makes sense? Everybody okay there?
I think so.
Okay, so wouldn't this be the radius of the cylinder?
Probably.
Sure.
Yeah, because that would be the diameter going all the way through.
Why is it a cylinder and not like a box?
Well, because it's just round. It's going around. Picture a bottle.
Oh, so it's a really thin cylinder.
Yeah. Does that make sense? Yeah. All right. So let's think about an integral here. I can actually pull the pi outside because that's a constant. All right, so we've seen integrals before. We can move the constant to the outside. We'll call that A. We'll call that B. I know that's 0, but I'll just call it A for this case. Now, the one thing that you notice is as you move along and you find all of these slices, the radius changes, right?
Yes.
Because the radius is from the function. Squared. So squared. Remember, h was the height there,
Okay.
which became our dx. Now, how many of these cylinders or discs would you need to get an accurate volume? Infinite. So, these right here just aren't going to be good enough. They have to be infinitely thin, get them all in there, right? That's the idea of the integral. So remember, the integral was like the infinite Riemann sum, infinite number of rectangles. Now we just have an infinite number of cylinders going through. Does that make sense?
Yeah.
Right? Now, this is what we call a disk method. Disk because there's no gap in between. A washer assumes there's a gap in between. So, a washer, just like with nuts and bolts, a washer,
Yes.
where you have the outer circle area minus the inner circle area.
Yeah.
A two-dimensional piece. So that's the subtraction coming out, taking out the inside one. Now, when we did area, I had you make sure, good idea, put the zeros in. Okay? Even if it was a 0, you still wrote out subtraction. A 0 because you're keeping an idea of what's on top, bottom, so forth. Okay? So a lot of times it's going to be easier for you to think of everything as a washer This one would just be minus 0 squared dx for that shape, because there's no inside to take out. But it'll remind you to look for that inside piece. Are you okay with that? So let's get a few pictures up here. Develop the integral. Then we'll look at an actual problem. But all right, so if I was going to take, I'll call that f of x, call that g of x. And we're going to take that region right there. And we're going to rotate this about the x-axis. We're going to take it about the x-axis. So that means that it's going to be down in this part. So we wouldn't have any gap right here at the origin, but you start getting a bigger gap as you go. So picture that thing being rotated around. Everyone okay with that?
Yeah.
Okay. Here comes my setup. And I'll just call that B, A. Pi, A to B. The outer radius would be from F to 0. So F to 0 is going to be the largest part of the radius. The inner radius would be G to 0. So we're going to have f of x minus 0 squared minus g of x minus 0 squared dx. Now, I know that the zeros aren't going to make a difference here when you're working in your calculator or evaluating anything, but it'll help you keep things straight. Remember, it's either top minus bottom or right minus left. We're going this way. So we are definitely top minus bottom. So top minus bottom would be f of x to 0, because this is what we were rotating around right there. There's your outer radius. Inner radius, g minus 0. Still top minus bottom. Okay there? Let's do a different setup here. Same figure. This time we're going to say about y equals negative 2. So this is just going to be a bigger rotation. So instead of rotating around the x-axis, we're going to be rotating around this guy. So it's just going to make a bigger gap in there. Everybody okay there? So in other words, let's see if that's 0, 2, 3, 4. This one's now starting. It's down here. Think outer radius minus inner radius. So I know it's still pi integral a to b. That part up there quick. You can see my limits. Got my pi piece there. Outer would be from f, top. The bottom is negative 2. So not f to 0, f to negative 2. That's going to be that outer piece you're rotating around, that outer radius. So we'd have f of x minus negative 2 squared. Inner radius, g to negative 2. So I'd have g of x minus negative 2. Squared dx. And I would encourage you, especially here in the beginning, I know minus negative 2 is a plus 2, and that's the way you'd see it if written in an answer key or something, but write it like this because it's reminding you, hey, I subtracted out that bottom. Everybody okay there?
Mm-hmm.
All right. Let's change this. I'm going to say that y value is, I'll say a 7. All right. So we're going to go about y equals 10. Okay, y equals 10. Look at where that is. That's above the figure. Everybody agree with that?
Yeah.
So now we're going to be going up this way. 10 sitting up here. Picture like top of the board. This figure is going up around the top of the board. Everybody okay with that?
Okay.
Okay. What's on top? The figure or 10? 10. Right? So volume, pi, integral, a to b. Get that out of the way. Outer radius. Now the axis of revolution's on top. There's 10. The outer radius would be from 10 to g, because g is the furthest away. So from here to g is the outer radius. From here to f's the inner radius. So it would look like this. 10 minus g of x squared minus inner radius 10 minus f of x squared dx. Okay there. Now I'm not worried about, I don't have functions up here, but if I had actual values for these functions, we could put them in. The calculator can do the integral. It's the setup's the key, and that's what we were focusing on in the area. Got to get that set up right. But you all right with the difference between these two? Below, above. Okay. About y-axis. So picture your figure rotating about the y-axis. Rotating about the y-axis. We're going to have to go this way, right?
Yes.
So the outer radius would be from g to 0. If we're going to go this way, it's right minus left. This way is top minus bottom. Now you're coming this way, right minus left. So on the right side, g to 0 is the outer, f to 0 is the inner. Does that make sense?
Yes.
All right, so here's my setup. Volume, pi, integral. And based on what I have up there, I'm just going to say 0 to 7, because if I've got y's in there, I've got to have y limits. So I'm just going to use 0 to 7. G of y minus 0 squared minus f of y minus 0 squared dy. So what we're going to see is we've got to make sure we're in the correct variable. So when you did area, if you were doing right minus left, you had to be in terms of y. So this may be g of x or y equals something, but I'd have to turn around and solve it for x, and that would be in terms of y then. So right minus left. Are you okay there?
Mm-hmm.
All right. Let's say b is about 5, roughly. Let's go about x equals 8. So picture where 8 is. X equals 8 is a vertical line, but picture where it is relative to the figure. So we're here on the right side of the figure. Vertical axis of revolution. So we're still going this way, which means we still need y's. So now I'm going to have volume, pi, integral, 0 to 7. There's my y values. I'm going to have a dy out there at the end. The outer radius, 8's over here, would be from 8 to f. Again, right minus left. 8 to F is the outer. 8 to G is the inner. Okay with that? So again, from 8 right side minus left side. That's furthest away. There's the outer radius. Further distance. There's my inner radius, 8 minus G. So this is my setup. 8 minus F of Y minus 8 minus G of Y. Okay there? All right, let's change our figure here. Let's go with y equals x squared. Y equals 0. X equals 3. And this will be creating my region that is bounded. Some of you are really good at visualizing and so forth. I would suggest just get a rough sketch down because it helps you see which way things are moving. Okay, just get a rough sketch. Doesn't have to be perfect. You know what x squared looks like. That's a parabola. Something like that. Y equals 0 is the x-axis. That's this guy. X equals 3. There's a vertical line over here. So that makes this the region I'm talking about. Are you okay there? Some of you will be really good looking at all that, picturing it and working with it. Others, maybe it's better for you to kind of pull it out. I know for me, it works real easy if I just separate it from the rest of it, because then I can go, all right, that's 3, that's 0, that's the 0.39, because 3 squared is 9. Then I'm looking at just that piece. Depends on the person. All this other extra stuff going on might not bother some of you, but if it does, hey, redraw it, clean it up a little, or use pencil, just erase what you didn't need. Something like that. So now let's get them set up. We're going to go about x-axis. Again, we're going to focus on the setups here. Your calculators can evaluate it. You know how to work your calculators. Okay, get the setups right. So I'm going to take this piece and go about the x-axis. We're going to go this way. That will be top minus bottom. I'm going to have volume, pi, integral 0 to 3. Top minus bottom, I've got x's in there, x limits, dx out on the end. Outer radius would be from the function to my axis of rotation, which is 0. So x squared minus 0 squared. My inner radius, it's actually butted up to the axis of revolution. So the inner is just 0 minus 0 squared dx. So in other words, there is no inside. Now I think it's really important in the beginning here to just put those zeros in, because this is what you're going to see in the back of the book, or if you're looking at an answer key. Where in the world did that come from? Simplified it out, you don't really need the zeros. But I think the zeros do help you. It reminds you, hey, let me take that bottom out. And there was no inner. So I've turned that disk. So this would be what you consider a disk because it's butted up to it. There's no gap between. But if I still treat it as a washer, I'm looking at it the same way and I'm just not taking anything out. Are you okay there?
Yes.
And we'll move the axis of rotation. About y equals 12. All right, that's a horizontal axis. So I'm still going to have top minus bottom, which means x's. So I'm going to go ahead and get my pi and 0 to 3 out of the way. Okay, so where's 12? Is it above, in the middle of, or below my region? It's above the region. Right, so we're up here. So my outer radius would be from 12 to the outermost function, which is 0. So I would have 12 minus 0 squared. Then my inner radius right here, 12 to the function. So 12 minus x squared. You okay there? Let's go about y equals negative 2. All right, where's negative 2 in relation to my figure?
Lower.
Lower. Okay, so still a horizontal axis of revolution. So pi 0 to 3, get that out of the way. So negative 2 sitting down here. So my outer radius would be from the function to negative 2. Notice still top minus bottom. This function to negative 2 is the outer. 0 to negative 2 is the inner. So I would have x squared minus negative 2 squared minus 0 minus negative 2 squared dx. Okay. And again, at this point, I would encourage you, still put the minuses in. I know minus and negative 2 is a plus 2, but it'll help you remember right now, hey, I'm subtracting. The more you do, you'll start leaving that part off, but this helps you keep everything straight. Got it good there? About y-axis. So now we have a vertical axis of revolution. We're going this way. That means I need y's in the figure. I've got to have y's inside the integral. Means I've got a dy, which means I have y limits. Pi integral 0 to 9. That was my y value here. So 0 to 9. I'm coming this way. Right minus left. What's the outer radius? 3 to what? 0. Okay. So 3 minus 0 squared minus. Now my inner radius would be from the function to 0. Okay. But I got to have it in y's. So this would be the square root of y minus 0 squared dy. So I've got this y equals x squared. I can solve this for x. I can get x alone. That'll be the same as x squared y. So if I have to switch variables, I've got to solve for the other one. Everybody okay there? Let's look at one more here. Same one. Let's go about x equals 5. Visualize where x equals 5 is on your figure. It's a vertical line. Is it left of the region, in the middle of the region, or to the right of the region? Right? X equals 5.
Okay.
X equals 5. Give you a hint. It'll never be in the middle because you can't. Now the figure's all messed up, right?
Okay.
Trying to rotate it around. It's either going to be left or right or top or bottom. So x equals 5 over here. All right, so we're going to have, again, a vertical axis of revolution. Pi integral 0 to 9. Get those out of the way. Okay. All right, 5's over here. So is the outer radius 5 minus 3 or 5 minus root y? 5 minus root y, because that function's further away. Squared And the inner is that 5 minus 3. You okay there?